Hi, this is Mohammed. Now I was going to explain Python deep learning ICP7, and my team member is Yoma Desai. So in the first program, we need to implement the uh, classifiers. So and find the find the accuracy of all the classifiers whatever we had used. So and then by adding few of the parameters uh, to these classifiers, and then again we will be calculating the accuracy to find what the change is, how the accuracy is increased or decreased. So firstly I was importing all the required libraries here. So here the main data set will be using like a fetch 20 news group. So this is a news group collection of a 20 news group having nearly 20,000 documents. So after training this model, so we'll be predicting the new document, so which category this new document will belong. So like this we can perform the analysis on by using the fetch 20 news groups. So I was inputting all the required libraries like count factorization for converting the text into vectors. And then TF-ID, the same thing it will be doing, and then metrics pipeline, and then importing a multinomial DB classification algorithm, SVC, linear SVC, KNN algorithms, and then finally I was calculating the classification. I was showing I need to show the classification report, so that's why I was importing this function, and then stopwords. So yeah, firstly I was reading the data. So in the data itself, we'll be having the train data. So that's why I'll be reading the train data set. And then this is the target data. So here I was printing the target column. So there will be a 20 categories where all these 20,000 news group belongs to. And then this is I was printing the train data, 20 train data. So here you can see these are all the documents. And then next I was implementing the model based on these classifiers. So I will be had selected the SUM and then KNN, and then calculating and then finding the accuracy for each of these algorithms. So actually the machine learning and the deep learning algorithms can't predict directly on the text data. So what here we'll be doing, we'll be converting into the vectorization form. So actually we will be having the text data. So what the here, so we need the vector form, numerical form. So what here we'll be do by using the TF-ID vectorizer, this function will convert all these data into numerical. So firstly this text data will be converted into the categorical, and then categorical data, and then next it will calculate the frequency of each word. So we will be having the three techniques like count vectorizer, TF-ID factor, and then co-occurrence vectorism. But here TF-ID vector is the most most commonly used vector form. So that's why I will be using. Firstly I was creating the object, and then I was training the model on this train data. And then here I will be creating the SUM algorithm or SUM object. So I was training the both train data and the label, the target column. So after my data will be trained, and then I was performing the prediction on the test data. So I need the test data. So I was reading the test data from this first 20 news group, and then I was fitting the data, fitting the data. I was transferring the data, so it will be converted to vectorizer form. Finally, I will be predicting on the test data. So here I was calculating the accuracy. So finally, the accuracy is 81.86. And then here I was printing the classification report by using the function classification report. So you can see the precision recall and support. And then the next algorithm I had used the KNN. So the number of clusters I had taken is 3. The same way creating the KNN object, and then training the model, implementing the model by using the trained data set, and then by that model we are predicting the finally predicting the test data. So after after the calculating the accuracy, we have the KNN accuracy is 65.79, and then the classification report. And then finally what we'll be doing, we'll be adding a few of the parameters to the vectorizer, and then finally checking the accuracy whether it got increased or decreased, like how the accuracy changes happen. So here in the same way, I had created the TF ID after vectorizer object by adding the parameter n-gram equal to 1 comma 2. I mean, it's a bigram. And similarly, I was creating the SVM object and then implementing the model, building the model, then finally predicting the model in the test data. And then here you can see the accuracy 80.43. So when using the bigram, my accuracy got changed, like it reduced nearly 1% of the accuracy. So here the classification report 20. Then the last one, I will be using the vector. The same way I will be using the stop ports as a parameter. So here you can see created and then the same implement building the model by using SVM, then testing and then predicting. And finally the accuracy you can see 82.53. So there is an increase in the accuracy. Okay, and then the second one actually it's we'll be providing one URL URL, and then I need to collect the data from the URL, the paragraphs. So what will be by using the beautiful soup library, I was extracting the data from that URL. So here in the first 3 steps, you can see the same, importing the necessary libraries and then extracting the data. I was creating the HTML content by using this. So finally, in the BS object, we'll be getting the HTML document. So here you can see this is the HTML document data, and by from that HTML document by using the find all function, find all P is a notation for the paragraphs. So I was extracting that in paragraphs from the HTML document BS object. So I'll be getting like it was also included a paragraph P notation. So that's why again what I'll be doing here, I'll be removing the data. I'll be removing that P tag. So what we'll be doing, I was extracting the only the information, exact data from the from the object, and here you from the object parameter, from the object variable. So here you can see, and then I was finally printing the data. So these are my exact data present in the URL. So what will be here, I will be performing the data pre-processing, like stemming, tokenization, everything, whatever the NLTK to NLTK will be having. So firstly, I was importing the object, importing the NLTK, and then down P punctuations function. So and then next the sentence tokenization I was doing. So here the data will be splitted into the sentences. So this actually sentence tokenization is used to predict the starting and ending words. So yeah, by using the send tokenize function, I was we got a sentences on this particular data, and then again word tokenization. So here the word tokenization, what it will be doing, it will be converting, it will be splitting into the each word. So by using the word tokenize, we got each word of the particular data. So by using what I will be doing here, by using the for loop, iterating for 5 times, so I was printing instead of the entire data set. So here you can see, and then parts of and then next the parts of speech. So here the each of word belongs to which particular parts of speech, like we have noun, one, noun, pronoun, adverb, verb, adjective, interjection, like similar way. So in the similar way, I was downloading the library. This is the average processing tagger, and then by using this function POS tag, and the particular word will be the particular parts of it will be assigned to the each word. So here you can see. The next, the stemming is nothing but the getting the root word of getting the root word. So for example, if there is a working, will be get like the root word will be work. So similarly, so there are 3 types of stemmers, like Porter, Lancaster stemmer, and snowball stemmer. So I was importing all these and then creating then objects, and then printing for the first 10 words. So here you can see the for like it will be like the Lancaster stemmer, the root word it took as a LIC for the snowball stem, like regular one, like. And the lemmatization is nothing but it is similar to stemmer, but here it will take the root word based upon the parts of the speech. So like if it is a being, then it will take B. So in the similar, like actually the default the default parts of speech, it will took like it will be in the noun form. So in the similarly, I was so importing the word net lemma is the function, and then I was printing the first 10 words. So here you can see, and then next the trigram. Trigram, we will be having the unigram, bigram, and trigram. So here the each sentence will be like we'll be getting a pair of words. So for the bigram, 2 words, and the trigram, 3 words from the sentences. So after importing the necessary library, I was printing them here like a unigram, bigram, trigram. This is the sentence, and here you can see the unigram, bigram, trigram. Then find the name entity recognition. So in the name itself, you can see the name entity. So it will be giving them the particular word which belongs to for which it belongs to few parts of the speech, and then also the object like location and organization. So it will be showing these things. So I was doing the same thing by using the library, by using the required functions. And then finally, need to plot the frequencies of the word after removing the stop word. So here I will download the stop word function, and then here so actually the stop word. So here you can see the stop word. I was printing for stop word. So I me myself. So in my data, I got a word like I. So it's in a capital letter. So actually, what I will be doing is to remove the stop word. I was converting my data into a lowercase. So yeah, I converted the entire words into a lower, and then I was removing the stop word from my data from my word list, and then finally printing them. Finally plotting the word frequency by using the Seaborn library. So you can see. Thank you.